Today we are going to see about retardation or running down test and Swinburne test of DC machine. This is a circuit diagram for retardation or running down test on DC machine. So we are going to discuss the retardation test on DC machine. The retardation test is also called as running down test. This is very efficient way to find our slave losses in DC shunt motor. In this test, we can total slave losses nothing but the combination of mechanical friction, windage, and iron losses of the machine. The procedure for retardation test on DC machine. Now, to start the DC machine, normally run the machine slightly above the rated speed by adjusting the resistance. After achieving the rated speed, just to cut off the power supply to the armature, but keeping field normally excited. Now wait for some time to fall down the speed below the rated, then using tachometer note down the value of speed and time. Since both B core and B friction shunt motor remains practically constant for no load to full load. Some of these losses called constant rotational losses. In the Swinburne test, the constant rotational losses comprising the core and frictional losses is estimated from the above equation. After knowing the value of B from the Swinburne test, we can estimate the efficiency of the motor, any loading condition. Let the motor load at such a new current drawn for the supply is IL and new armature current is IA. Let the field current of machine is adjusted. The second machine is acting as a generator with armature IAG and first machine acts as a motor with armature current IAM. Hopkinson test. This is an elegant method of testing of DC machine. So here is still shown that while the power drawn from the supply only correspond to the no load losses of the machine. The armatures physically carry any amount of current. Such a scenario can be created using two similar mechanically coupled shunt machines. Electrically, these two machines are eventually connected in parallel and controlled in such a way that one machine is acts as a generator and other is acts as a motor. Procedure. Connect the two similar coupled machines shown in figure with respect switch open. The first machine is run as a shunt motor at rated speed. It may be noted that second machine is operating as a separately excited generator because field winding is excited and driven by the first machine. Now the question is what will be reading of voltmeter connected across the open switches. The reading may be either close or twice supply voltage and small voltage. In fact, the voltmeter practically reads the difference of the inter voltage in the armature machine. Loading the machines. After the machine was successfully connected in parallel, we go for the loading the machine, that is increasing the armature current. Just after paralleling the ammeter reading, I will close as 0. So it becomes greater than the EB and both I lag and IM increases. Thus to increase the field current of generator, one can make EG greater than EB. So to make the second machine act as a generator, first machine act as a motor. So it is also required to control the field current of the motor. Maintenance speed is constant.